let's consider the case of flipping a coin twice and getting 2 heads. Okay, so we've just looked at how to make a probability tree to think about the possibilities there. So we've got half the time we'll get a head, half the time we'll get a tail on the first flip, and then on the second flip, same thing. So we've already got a head here, and then half the time you'll get a head and half the time you'll get a tail. Here you've already got a tail, half the time you'll get a head, half the time you'll get a tail. Good, so a quarter of, and all these things are equally likely, so a quarter of the time you'll get each of these. Good. And so now what I'd like to think about is how to think about this using a different notation and just using an equation to work it out. So if we say P and B, the way we would write that is the probability of A and B. So this symbol here this means and. And in fact, if we work it out, so we know that the probability of A and B is the same as equals the probability of A times the probability of B. So if we translate this into that same notation, so this is the first roll, the second roll, so the probability of rolling a head, probability of flipping heads on the first one and heads on the second one is equal to the probability of heads on the first times probability of heads on the second. So the probability of heads on the first is 1/2, and the probability of heads on the second is 1/2. So 1/2 times 1/2 is 1/4, so we come to the same thing. So you can do that the same way. So this is an important thing to remember, this and notation. I like to remember that it's an upside, it's like the n in and. You'll see that the symbol for or is quite similar, but I remember it that way. Good, so that's another example. So if we roll 2 6-sided dice, and how about 2 6s, and how about the probability of rolling a double? So first of all, we're going to do this kind of manually, and then we're going to use this equation. So here we've got the different possibilities from the 2 different dice. So we can roll a 1 2 5 6. So this is the first dice, this is the second dice. You can have 1 2 3 4 5 6. So here I'm going to draw out all the different combinations we can get. So you can have a 1 and a 1, a 1 and a 2, 1 and a 3. So I spared you writing all those out. So here we've got the 36 different combinations that you can get from rolling 2 6-sided dice. So the first question, what's the chance of getting 2 6s? So that's just this one over here. And if we write that out using this notation, so that's the probability of getting a 6, let's write an S for 6 on the first, and a 6 on the second. So that's the probability of a 6 on the first times the probability of a 6 on the second. So that's 1 in 6 times 1 in 6, or 1 in 36. And indeed, there are 36 possibilities here, and they're all equally likely, and one of those is a double 6. Now, how about a double? So that's any 2 numbers that are the same each other. So that could be 2 1s, 2s, 3s, 4s, 5s, or 6s. So here you can see there are 36 different possibilities, and 1, 2, 3, 4, 5, 6 of those are doubles. So that's 6 out of 36, or 1 in 6. So in fact, that is the probability. So really what we're looking for here is that the probability of the second roll will be the same as the probability of the first roll. So the first roll could be anything, so that's 1 over 1. Because it could be anything, we don't care if it's 1, 2, 3, 4, 5, 6. So any of those can be the starting point. Any of these possibilities can be the starting point. But then the second one has to be that exact same one, so that's 1 in 6. So that's the same as what we worked out by drawing it all out longhand. So any first roll 1 in 6 chance of the second being the same. So my main point here is that we've got an and, then we multiply the different probabilities together, and I've shown you that a couple of different ways.